What's going on, guys? Let's do this curve sketching. So in order to do curve sketching, we have to know 8 things. So first of all, we have to know the domain, intercepts, symmetry, and asymptotes, also intervals of increase and decrease, local max minimum, and concavity and the points of inflection, and finally we sketch the graph. So in this case, first of all, let's start with the domain. So in this case, x can be any real number, but if you see the denominator, we have x square, but denominator cannot be 0, because if the denominator is 0, this will become undefined. So denominator is not equal to 0, therefore x can be any real number except 0. So that's going to be our domain. So let's say domain is x can be any real number but not equal to 0. So this is our domain. Then the second one is we have to find the intercepts. In this case, if I start the y-intercept, y-intercept is when x is equal to 0. But we found out that x cannot be equal to 0. Therefore, there's no y-intercept. No y-intercept. No y-intercept. And then we have to x-intercepts. So x-intercepts is basically when y is equal to 0. So if I set this y is equal to 0, this will become this x square, go to the other side and multiply this one and becomes 0. Let's write this one to make it clear. So x minus 1 over x square. So denominator you don't have to worry about it, because if you bring this to the other side, it's multiply and becomes 0. And therefore x minus 1 equal to 0, therefore x is equal to 1. That's our x-intercept. So this is our x-intercept. Then we have to find whether it is symmetry or not. So for that one, what you have to do is, so this is f of x is equal to x minus 1 over x square. And if I want to find whether it is symmetry or not, what I have to do is I have to plug negative x and see if I get the same value as this one. So if I plug the negative x for this one, negative x, what I will get is negative x minus 1 over negative x square. And in the top I can take the negative 1 common, so it's going to become x plus 1. And in the bottom, negative x square can be written as x square, because both of them are same thing, but it's not equal to the f of x. If you see, f of x and f of f minus x is not the same thing, therefore there's no symmetry, not symmetry. And the fourth one, so let's say a b c. So we are doing the d right now. So in the d we have to find the asymptotes. To find the vertical asymptotes, what I have to do is I have to make the denominator, set the denominator equal to 0. And if I set the denominator equal to 0, that's going to give us a vertical asymptote. So in this case, if I set the denominator equal to 0, that's going to become x is equal to 0. And from this domain, we already know there's no point in x. There's no point is going to be on x. There x is equal to 0. So that's a clue you can get before you do this. And this is our vertical asymptote. And let's find the horizontal asymptote. So to find the horizontal asymptote, we have to set when limit x approaches infinity, what's the y value. So in this case, if I want to find that, uh, so let's write this down. So this is our equation right here, x minus 1 over x square. So when limit x approaches positive or negative infinity, what's going to happen is, so before we do this, we divide everything by the highest power. So in this case, I divide this one by x square, 1 over x square, x square over x square. So in this case, 1 over x square is going to be 1 over infinity. So it will become x over x square is going to be 1 over x minus 1 over x. Let's do this one. So if I divide this one by everything by x square, I will get 1 over x minus 1 over x square over 1. So in this case, x is, if you substitute the, so this is still limiting x approaches infinity. So if I substitute the infinity right here, what will I get? I will get 0 right here, because if you divide the 1 by infinity, it will become 0, right? So this is going to become 0. 0 minus 0 is 0, and 0 divided by 1 is going to be 0. And that's our value. Then you can plug this value in the limit and see whether it is true. 0 minus 1 is 0, divided by 0 is 0. 0 divided by 0, that's going to be, so that should give us infinity, right? So when you plug this value, so that's how we get this value. So this is our horizontal asymptote. And no, are we finding the horizontal? Yeah, horizontal asymptote. Also, we know this is true because it's already here. It's already here, right? So this is horizontal asymptote is y is equal to 0, and vertical asymptote x is equal to 0. So these are the points we have to know. And then the next one is intervals of increase and decrease. To find this one, I have to take the first derivative of this one. So first derivative of this one is going to be, I have to, okay, y prime is equal to x minus, so I have to do the quotient rule right here because it's dividing each other. Therefore, let's do the quotient rule. So if I do the quotient rule, it's going to become like x minus 1 prime multiplied by x square minus x minus 1 multiplied by x square prime divided by x square square. So this is going to be quotient rule. In this case, x derivative of x is going to be 1. So this is going to be 0. So 1 times x square. And then in the other side is going to be x minus 1 multiplied by the 2x. So 2x. And in the bottom we are going to have x power 4. And if you simplify this one, you will get, so if you simplify this one, so we are in the e, so if I simplify, I will get 2 minus x over x cube. So that's what it comes out to be, and that's y prime. So now we can check all the increasing and decreasing. So to find the increase and decreasing, what I have to do is I have to take the critical points. So critical points is, first of all, we know this is this one, like there are two conditions for critical points. First, we set this one equal to 0, and also the other situation when there's no, like, there's situation that gives us undefined. So in this case, 0 will give us undefined, so that's going to be a critical point. So x is equal to 0 is a critical point, and if I set this equal to 0, this is going to be 2 minus x is going to be equal to 0, therefore x is going to be equal to 2. So that's also a critical point. So now we have to check the values in these intervals, in the critical point interval. So we take the 0 and the 2, and before 0, if I pick up a number like let's say -1, so if I pick the -1, 2 minus 1 is going to be 2 plus 1 divided by -1 cube. So -1 to the power odd number is going to be negative number, because power cube means it's odd number, so it's odd number. If you power them, you will get a negative value. So in this case, we divide the positive number by negative values, therefore it's going to be minus minus minus, and this is going to be decreasing. And then if I pick up a value that's between 0 to 2, let's say 1. So if I pick up the 1, what's going to happen is 2 minus 1 is going to be a positive number divided by a positive number, that's a plus, so that's increasing. And then if I pick up a number above 2, like let's say it's 3, so 2 minus 3 is going to be -1 divided by 3 cube, that's going to be a positive value. Negative divided by positive is going to be a negative value, then that's going to be decreasing. So that's these are the increasing and decreasing points, and local minimum and local maximum. So in this case, this is a possible minimum, but there's no minimum gonna exist, because we found out in the domain x is not equal to 0, right? So therefore this is not going to touch this graph. This point is not going to touch. Therefore we can't say there's a minimum in this one. But we are going to have a local maximum in this point. It's going to be at 2. So 2 is going to be local maximum. So we have to plug this value in the value in the equation given. That's going to be to find the y value. So this is my x value. To find the y value, I have to plug this value. So it's going to be 2 minus 1 over x square. So 2 minus 1 is going to be 1. 1 over 2 square is going to be 4. So 1 over 4. So 1 over 4 is the local maximum point. So local maximum point, and that's the only point we have. So that's it. And let's move to the G part. So this is my F part, local maximum minimum. So G parts, we have to find the concavity and points of inflection. So in this case, what you have to do is we have to take the double derivative of this one. So we have found first derivative already. So y double prime is going to be 2 minus x over x cube. In this case, it's also dividing each other. That means we have to use the quotient rule in this situation. So let's use the quotient rule. So it's going to be 2 minus x prime multiplied by x cube minus x cube prime multiplied by 2 minus x and divided by x cube square. And it's in this case, if you simplify this one, you will get the answer that comes out to be 2x minus 3 divided by x power 4. In this case, what we have to do is we have to do the same thing as we did before. We have to pick up the critical numbers. So first of all, there are two possible critical numbers. First of all, one is going to be situation where the equation is undefined. So in this case, we have a x4. If the x is equal to 0, that's going to be undefined. So that's going to be one of our critical number. So I divide this one separately right here and continue here. Okay. So this is going to be x is equal to 3, 0 is the critical number, and I have to find the other critical number. I have to set this equation into 0. So if I set this equation into 0, it's going to be 2x minus 6 is equal to 0. So 2x minus 6 is equal to 0 mean, so let's write this down. 2x minus 6 is equal to 0. Therefore 2x is going to be equal to 6. S is going to be equal to 3. So these are the two critical numbers we have. So let's check the values in between them. So I have a critical number that's 0 and I have another number 3. And if I check the values right here, so first of all, let's plug the value below 0. So if I plug the value, let's say I plug negative 1. Negative 1 is going to give what? Negative 1 minus 3 is going to be negative 4. Negative 4 times 2 is going to be a negative value divided by x power 4. So we have a even power number. So even power, if you power a negative number by even, it's going to give you a positive number in this case. So therefore we are going to divide the negative number by positive number. That's going to give us a negative value. So this is going to be a negative value. Therefore this is concave down. So we can say CD. So it's going to concave down. And then 0 to 3, we have to pick up a number between 0 to 3. Let's say 1. So if we pick up a number 1, then what's going to happen? 1 minus 3 is going to be negative 2. Negative 2 times 2 is going to be negative value, and x power 4. So 1 is a positive number and power is going to be positive value, but is in the top we are going to have a negative number, because 1 minus 3 is negative 2 times 2 is going to be a negative value. Negative value divided by positive value is going to be a negative value. So this is also concave down. And the other hand, we have 3, and if I take values above 3, let's say 4, if I take 4, what's going to happen? 4 minus 3 is going to be 1, and 2 times 1 is going to be a positive number, divided by 4 power 4. 4 power 4 is a positive number. A positive divided by positive is going to be positive, so it's concave up. Now we have all the information to draw the graph. So let's begin. So these are the points we have. Okay, we have to know the main points. So we have to know 1. So we know we have a intercept as 1. So this graph is going to cross this at this 1. Also we know that 0 is our horizontal asymptote and vertical asymptote. So there's nothing going to touch in 0. So that's also we have to know. And then we also found out that our local maximum at 2. So when it's x is equal to 2, there's a local maximum. So this is 1, this is 2. So let's say this is at 2, there's going to be a local maximum, and it's going to be exactly at 1 4 from the y-axis. So let's mention this one right here. And then and then also we found out, so we have to find the inflection point. So in this case, so inflection point we can find it from the second derivative test. So in this case we have found 0 and 3 critical numbers, but this is negative, concave down, but at 0 we found out already there's no value exists in 0, because it is not in the domain. So that's not going to be a inflection point. But in this 3, in this 3 because we are going to have an inflection point because the sign is also changing, and that's going to be an inflection point, so we have to be, so that's concave down to up, and that's going to be 3, right? Inflection point is 3, and I have to find the value at 3. Let's see. So if I plug this value 3 minus 1 is going to be 2, 2 over 3 square is going to be 9, 2 over 9. So 2 over 9 is going to be my y value at 3. So let's plug this value right here. So let's say this is 3, and at 2 over 9 we are going to have an inflection point. After that it's going to be concaving up. So we found out this is concave down, and it never touches 0, and therefore the graph is going to be something like this. So it's reaching the 0 but it never touches it. So this is my graph in the left hand side. In the right hand side we are going to have we found out it's, so we found out this is going down because it's decreasing below 0, that's why it's concaving down. So in case if this is increasing, that's going to be a different thing. And in the above 0 we found out that this is increasing, therefore it's going to be starting from the bottom and it's going to go up all the way, and we know that this is a local maximum, therefore it's going to be turning down from this point forward, and then we have an inflection point at 3. After that it's concaving up, so it's going to be turning up again, and it's going like this. So that's how our graph is going to be look like. And this is all about curve sketching, and that's it. I hope you guys like this video. See you next time.